and Python scripting unlocked. And we wanted to start a series where we actually talk about how you can use node editor, Python scripting, how you can do your custom rigs in Cascader, how you can create your scripts in Cascader. And to start, to get you going, to start with this topic, we will first today cover this plan, and it consists first with starting of how Cascader is structured inside, because like before using the tools to change the rig, you have to know what the rig is, and before using Python scripts to control the components of Cascader, you have to know what actually Cascader consists of, how it looks like from the inside, what is its architecture. So that will be our topic for today. We'll try to cover it. I'll show on a really very easy example creation of some points and create some constraints between these points, and how the update system works in Cascader. And then we have some questions that were asked by our users beforehand. We'll answer them, and we'll also of course answer any questions that will be from the chat. Okay, so let's start. Let's start with the Cascader overall structure. So here is the whole program, and I'll be returning sometimes to this list of topics. I didn't learn by heart too much, so just to not get too far away, I'll use this to keep close to the main themes. So, what Cascader consists of? Of course, we have the scene that we actually edit in Cascader, and probably it will be the best way to describe a scene, at least for me, from like the inner side viewpoint, is to say that actually all the work you do with something, you do with a scene, and then you save the scene to a file. So it very much corresponds with the file. You save the scene to a file, you load the scene from file. Okay, so let's stop at this for a moment and look at what other stuff do we have in Cascader. We also inside call main parts of Cascader components. So we have like this menu, we have the toolbar, we have the viewport, we have the outliner, we have the timeline. We call them components, as they are like the main components of the program. They are what actually makes the program itself. And then on kind of on top of that, we have a lot of different tools that let you edit this scene or visualize the scene sometimes. And these tools, they actually they have the ability to contribute to this basic component. So, for example, here's a tool, here's a manipulator tool, and it contributes a visualizer to the viewport. It contributes with this panel to the toolbar. It also has some settings in the scene settings, etc. We'll not dive too deep into this because for today's main topic, the node editor and the scene structure, we don't have to know too much about tools and stuff, but I think we'll get to them in our future streams or videos. We'll see how what will be the best way to kind of pass the information we have of how Cascader is structured and how you can use it to you, to our users. Okay, so let's dive in and look at the scene and what it consists of. And here, the main thing that makes up the scene are the objects. We can see them here in the outliner, and if we select some object, we can see the object properties here in the property editor. And here's where it gets kind of interesting. So we have to understand what is an object. What is an object from the perspective of the program, from the perspective of how the program is structured. An object, and we'll have to give some definitions here, and they are, of course, specific to the program. Sometimes I will give a corresponding definition that actually is used in other programs a lot. So an object, I would say, an object is a container. If you look from the programs, from what it does in the program, in the scene, object is a container. What it contains? It contains a set of, first of all, it contains a set of behaviors. And here let's just jump into a new scene. And to edit objects, we have this tool that we unblocked in the latest version, the node editor tool. So let's just create a node, and we'll create an object node. That's basically the main thing you can create here. Let's rename it, and we'll call it a point. We can see already now that this is that's the only object in this scene, and we can see that this object has two. It looks like there are two behaviors, but actually additional info is not a behavior. It's just a for property editor, like a visualizer to show what track the object is placed on. It's track node, track 0. And then we have this basic behavior. Actually, every object has this basic behavior, and we can edit the behavior list. Behaviors can be called also components. A lot of time in other programs, other software, they're called components. So how can we understand what this behavior is? It basically is a set of references, something that describes how this object will actually work inside the program. So this basic behavior describes what its parent is, is it visible, is it selectable, etc. But for now we can't see this object anywhere. If we select it, we just see the pivot, it's in 0 position. But we can, with this tool, with this behavior editor, we can actually add some behaviors to the object. Let's add a point behavior, and let's see what changes. And we can see this point here, but we can't move it. Try to move it, I can't do it. You might be wondering why we don't see the point behavior here. It's because automatically here we hide, if there are no attributes inside that the user can actually see, by default such behaviors are hidden. We can switch here to show all component type, and we will see it. It contains some of the GUID. So to move the object, we have to add a behavior that the translator works with, the manipulator translator tool works with, and this will be the transform behavior. We still can't move it for now because it lacks any references. Here are the attributes we can actually fill, and the first one we'll add is the global position. So let's create a new node. Here you can see that when we were outside, we could create object nodes. Inside an object, we can create other nodes, and one of them are regular data. Let's add regular data vector 3f. Let's call it position, but we could call it any way we want. And now we select it, and here's a very tricky thing, I know, but yeah, I just have to tell in advance that these tools, although we did polish them, they were even in worse condition, but they're still pretty raw. Overall, these tools, the node editor, the Python script, and like the structure of Cascadeur, it is, I would say, it is rather low level compared to other software. So it's low level, and the tools are pretty raw. So yeah. So what we have to do now is press Control, hold it, and with the left mouse button press here, and we'll set the position to this attribute global position. So let's look what happens now inside the program. Let's select our point, and we can actually move it now, and we can see the transform behavior here, and we can see this position, and it actually changes when I move the point. And what happens here actually is first, when we added point, there's a visualizer that draws all the points it can find inside the scene, and it sees, hey, here's a point behavior, and it checks if there is transform behavior inside this visualizer. Works like this, and if it sees this transform behavior, it reads the global position and it draws a point there. If there's no transform behavior, it takes the default value that transform behavior provides, and in this case it's 0, 0, 0, and so it draws a point just at this position. So yeah, and the translator tool and the pivot, which is a bit of a separate entity because it's not used only in manipulators, they also look at what objects are now selected. Do they have transform? If they have transform, let's read what's written there, and they see this global position, and you can actually edit this global position, and the pivot is placed in this global position. Okay, so let's now connect it like this. Actually, you know what? Let me look at my list here to see if I'm not missing something. Yeah. Okay. So what do we do now? I think it's more or less understandable now that object is a container that you can fill with different behaviors, and those can be they can be very different. For example, a mesh is also a behavior. Here we see it's a mesh object. It has lots of joins. It depends on, it has some other data connected to it. For example, here's a behavior manipulator locker. If you place a behavior like this, then it hides the manipulators, and you can change its properties and you will see this manipulators again. You can also see that when I change this value, boolean value, to allow to edit the x-axis. Rotate x and scale x are also changed, and this is because all these three properties look at one data. Okay, we'll cover it a bit later. Here's an FBX behavior. This behavior controls what is exported into the FBX. So if this behavior is absent, this object will not be exported to FBX. Okay, I could go on and on about these different types of behaviors, but I think maybe we'll cover them step by step when we actually do something. So right now, let's just go further and see what else we have. Yeah, I was creating these nodes. So you can see that object is a container of behaviors, but also you can see this node that corresponds to this object. And what is a node? It's a tricky thing to define a node, and I think it's pretty tricky for other software maybe too, but in our case, what is a node? Node has some input attributes and output attributes, and some of the nodes can be containers for other nodes. So when you create an object, you always have a node that corresponds to this object. And what is all this node structure about? All this node structure is about data and how this data is connected to each other. How we calculate some data, some positions, rotations from other positions and rotations. Here too, this is very low level, more low level than it usually is. For example, calculating global data and local data of objects is also all done inside this system. And if we look at all the nodes that we have, then we can actually say that we have a graph where there are nodes and there are connections between the nodes. So what can we do with this graph? What does it actually why do we need it? How do we actually work with this? I think that it would be best to look at this on some example. So let me just create some more of these points. For this, I'll go comments, copy paste object, and I'll duplicate the point, and I'll duplicate the point again, and I call them, just so it will be easy to navigate, I'll call them point 1, point 2, point 3. So I actually have 3 points right now. Now let's suppose I want this point. Okay, where's the point 3? Point 3. Suppose I want this point 3 to always have a position that is the sum of the positions of point 1 and point 2. How can I achieve that? Okay, let's go here to the root. I'll move point 3 here, and here I have point 1 and point 2, and I can connect these attributes. Let me call them correctly. I'll call this position 2, position 1 to show what point it corresponds to. Then I enter inside of this point, and I can add a node that will be called, and here all this, these are basically, I would say they're the IDs of the function. and I think we will prettify and make this stuff nicer. But for now, we'll work with it as it is. So let's add a node that is called sum vector 3f. So it basically just sums up all the vector 3f that come to it, and then it can write a result into a vector 3f data. And let me connect it. But nothing happens yet because it is not yet activated. We create them deactivated because they have no connections when we create them. So let's activate it. Let's actually see what happens when we activate it. Let me activate it, and you can see this point jumps here. And now, if I move the second point or the first point, then the third point will move. But if I try to move the third point, then it won't move. So this is basically the I don't know, the simplest example how you can constrain data, connect data. The position of point 3 is calculated based on the position of point 1 and point 2. But here we come close to a thing that to some noticeable differences that Cascadeur has, and it's that we can, if we want, change the system in such a way that when I move point 3, some of these points will move. Suppose when I want to be able to move point 3, and I want point 2 to calculate its own position in such a way that still this equation point 1 plus point position of point 1 plus position of point 2 equals position of point 3. It's really obvious, but I'll write it down just in case. So right now what we have, position of point 3 is point 1 plus point 2. So position of point 2 is obviously just position of point 3 minus position of point 1. So I want, if I edit the position of point 3, then I want position of point 2 to be recalculated like this. Let's go to the node editor and try to actually implement it. So we'll need the position. Okay, I'll do it this way. Position of point 3, and we're gonna subtract position of point 1 from it. Let's call this position 3, so it's easier to understand. Okay. Subtract point vector 3f, and so from position of the point 3 we subtract position of point 1, and then we want to write it to point 2 position. So let's try to activate it, and we see that there's a red border here. That means something is written here, and it tells us that can't change it. Error rig not a DAG. So yeah, I know not the most pleasant error, but let me say what DAG stands for, and you'll understand what it means. It means directed acyclic graph. So it says that rig does not form a directed acyclic graph. basically it means that it has cycles. Yeah, and we could change the error, of course, because it's certainly a graph and it's certainly directed. So, well, why does that happen? That's because now point 2 position depends on point 3 position, but point 3 position depends on point 2 position. So we have to understand when we want to calculate one way or the other. And to do this, we actually, inside Cascader, we have several graphs. Let me just draw it here. So first we have what we call a setting graph. And setting graph, it can read the values of different settings, and settings and data here are here will be different. And it can also it also has access. It knows what datas were changed, and then it calculates something with different functions, mainly Boolean functions, and it returns. It sends then to the data graph the information about which functions will be active and which will be inactive. And then data graph can actually do its work and actually calculate usually some float values like positions, rotations, etc. Okay, so let's create two setting functions. One will just copy the value of the actuality because we can't set it directly. It's like a technical limitation. So, and the other sorry, didn't connect it yet. So this function is true when this position is changed, and when this position is changed, we want, let's name it point 3 changed. When this position is changed, we want the function in the point 2 to be active and to recalculate the position of point 2. And if this position is not changed, then we want this function to be active. Okay, let's connect it here, and let's connect it here. So now I can actually activate this function. Let me clear the log. I can activate it, and everything is okay. There are no errors. So now I still can move point 2, and point 3 will change its position. I can move point 1, and I also can move point 3. And point 2 position will be recalculated. So that's a difference. That is, there are some ways usually how people do similar things, but in Cascadeur it's like one of the, it's encoded in the, I don't know, the basic architecture of Cascadeur, that you can actually switch which functions you use to calculate one way or another. We needed that for different reasons. For example, because we have a physical model, we have this rigid bodies, and they can be positioned. Let me show them here. They can be positioned in some way because of our relaxation process, and then we have to recalculate all the controllers based on how rigid bodies are positioned. We also it was a requirement that we can edit the joints, and the controllers will be updated. So yeah, it actually provides you with ability to create rigs where you can, for example, rotate the hand or just move these 2 points, and the direction controller will change its position. But you can also grab the direction controller and move it, and the points will change their position. Okay, so that's the main idea. Okay, maybe there are some questions in the chat, Ilya. Maybe we can make a little stop here, answer some questions if there are any, and then I'll continue to just finish with this update mechanisms we have in Cascadeur.
As I see, all guys in our chat are silently listening to you. There was only one statement that the node is equal to state. That's all. So I suppose that if you don't dare it much, I suppose that you can finish for this moment.
Can you repeat the statement, please? Because I don't have. I didn't actually open the stream, so I can't see the chat, which is certainly a
We have
an
one
error.
question. Yeah, and
Mistake.
the statement was node equal state. It was just in the beginning, so I suppose that it means that it's similar things. So to the questions. First question from Sweet Bytes. Can you use joints from a different 3D software? I want to preserve joint setups from Maya.
And by joints you mean like the bones that are passed via FBX? If that's true, then like this, you can import the data that is contained in the FBX, and those are the joints and the mesh that is skinned to them. Well, that's the data that Cascader right now uses. Yeah, so you can bring that in. But if you're talking about the rig that you use in Maya, then no, you won't be able to bring the controllers inside of Cascadeur. And usually the controllers are not like you can't drag them from one software to the other, because this update systems, they are unique. I don't know, maybe there are I've seen situations when people have some rig generating system, and this system works, for example, in Maya and in Unreal Engine, and then you can have a similar rig in the two programs.
There was an answer, just joints. The controls, I understand, are just interfaces for animators. The most important thing is the joints that deform them.
Well, yeah, usually what you get as a result of your work in Cascadeur are the positions and rotations of the joints. You export them, and then you can import them inside the game engine or inside Maya or some other 3D software, Blender. Okay, are there any other questions?
I don't see for this moment. We can wait.
Okay, let's move further. I think we'll still have some time to answer more questions. I wanted to continue with telling a bit more information about the update system that Cascader has. It's pretty complicated. Okay, so the update system. So we have actually what I the scheme that I drew here, it's just like the first step of the update system, and update system consists of 3 steps. So let's call it this just a I don't know, a graph update. And so usually what we have is that we have this graph update based on the data that the user changed, and then we have relaxation update, and then we have another graph update because after the relaxation rigid bodies will they will be positioned differently, and then we have to update the positions of the points and all the other objects based on how the rigid bodies are positioned. We can actually see this. Let me show rigid bodies here. Here's a setting that you have to know very good. You have to know Cascadeur very good to change this setting, because it can break different stuff, including Control Z. So let me just turn off interpolation for now, and the setting is called update level. I just want to show what it actually does. So if I select these points and I move them, then you can see how all the other objects move. I'm not showing joints right now, but they actually move to corresponding to how the points move. But if I move a point, for example here, you can see that other points around it are not reacting. That's because I turned off the relaxation, and the only thing that gets updated is the only the update graph works, and so this movement is not passed along to the other rigid bodies. So let me now change this update level to 2, and now the relaxation will also be called, and you can see how the rigid bodies are actually moving, but the points are not being updated based on how the rigid bodies move. And if I put update level to 3, then you will see how after the relaxation all the points and the joints actually to move. And you can see the same thing for interpolation, and that's because actually in Cascadeur, whenever you move something and you release the mouse button, then interpolation is called. And if you're familiar with other 3D software, then you could say that our interpolation is like it's close to what is called baking in other software. So you actually, let me turn on some interpolation. Okay, it doesn't seem to do much. Okay. And you can see here the trajectory. And if I go here, if I actually move the hand of the character, you can see the trajectory. It always shows what data I have in my animation, and you can see that On this frame, the hand actually moves into new position, and on the surrounding frames it stays the same. And once I release it, it recalculates, and now in all the frames there's a new position for the hand. And during this recalculation, and inside Cascadeur this is called interpolation. So usually how a lot of software work, you go to some frame, and then when you go here, the interpolation for the curve is called, and you get some position of all the controllers, and based on the controllers the position of joints are calculated, etc. In Cascadeur, whenever you create some change, all the interpolation in all the frames is recalculated, so we have all the position for all the objects, all the correct positions for all the objects. So that's like a basic difference, and allows us to, it's actually can be used as a big cache, because we actually want to we need all this knowledge for our physics tools to work. We also use it for tools like trajectories, for tools like hosts. So because of this, ghosts actually work very, very fast, and a lot of different other tools too. It also enables us to do some interesting stuff with interpolation, with the speed of interpolation, with the tangents. So let's get back. Also what I wanted to say is that, of course, what also we're talking about the scene structure. So scene structure includes the objects that are containers of behaviors, and that are also contribute to the update graph, and there's a node for each object, and many of these nodes contain a lot of different datas and functions. We can, for example, look at some node from a real rig. And you can see that it has a lot of input and output attributes, and if we go inside, then we'll see a bunch of datas, and we can see there's different update nodes that actually inside of them there are a lot of different setting nodes, and some of them there are different data nodes, data functions, datas. You can also see that there's a S and A marks here, and that stands for static and animation. So static datas, they have one value for the whole scene, and animation datas, they have different values in each frame, and animation values actually get interpolated during the interpolation. And also, in addition to all this information about the objects, and all the information about the data, what values each data has, including that for the animated datas and animation datas, we have to know and contain a value for each frame. In addition to all of this, we also have a timeline with frames, and on this timeline we have animation tracks, and inside the scene we of course we store the information about the hierarchy of these tracks, and we also store the information about like what intervals we have on each track, where the keys are situated, what types of interpolation we use, etc. So these are the main components of the scene. Also, different tools can contribute different data for the scene. For example, we have a auto-posing tool, and so if we use our auto-posing tool, we can actually edit some of its controllers, and if we now save the scene and load the scene, the information that this controller was changed in this frame, it is also stored. It's stored inside the scene, in addition to the information about objects and information about the animation tracks. Okay, so I think that's the main topics I wanted to cover. If there are any questions in the chat, I think we can answer them now. If not, I will answer the questions that were sent beforehand.
Yeah, we have several questions. First question is it possible to create rig setups with the controls off to the side, like the ones that are used for facial rigs? Those ones are parented to the root but control face joints.
Yeah, theoretically it's possible to create any rigs and controls. The only limitation right now, like a serious limitation that can like stop somebody from creating like any rig system they want, is that you can't contribute to UI. You can only do some basic stuff like create file dialogues, but you can't like create a widget and place some buttons, some text fields, etc. So that's a limitation. But theoretically, you can do everything. You can create a facial rig, and we also plan to do this actually at some point of time. But of course, it's overall it's possible. The set of functions might have some limitations, but if there are some functions you would like to see, like I don't know, we have clamp, for example, that is really needed in a facial rig, but maybe there are some functions that are absent. We will be happy to add them. But it's a lot of work for a facial rig. I think it's a lot of work. So it depends. It might not be that easy to create it. Okay, maybe some other questions.
Second question: what part of pipeline would you say the node auditor speeds things up the most?
Well, the only alternative for a node editor, like if we're talking about creating rigs, it's either our rig system that comes by default out of the box with Cascadeur. Then the only alternative to the node editor is Python scripting. So you can do all the same stuff that the node editor does via the Python scripts, and even more. But you'll have to like write a lot of lines of code to actually create anything. And if you wanna just pretty fast to experiment with different stuff, how we did here with the points, it's much easier to do it via node editor. And actually, without it, it's really hard to debug what's happening, what is connected to what. Before we had an editor, and I was creating the rigs, I had to draw by hand, on a list of paper, how the stuff is connected. So now it's much easier to do, to create rigs.
And the close connected question: what's the most complex rig that's been created so far using Cascadeur's node editor?
Well, I don't know if it's fortunately or unfortunately, but as we just released it, and I think it's a lot of work to create a full rig. I think our basic rig is the most complex thing created, and it was created partially with the use of node editor, and it all works via the Python scripts that are basically in the Cascadeur directory. So you can see all those scripts. They're here in the riggen folder. But that's a lot of scripts, and they actually load some parts of the rig, and we call them parts, but I don't know, if you're familiar with Unity, it would be called prefabs. I don't remember how they're called in Unreal Engine, but there's a word for them there. They are present there too. I just don't remember if the definition is also prefabs or something else. But yeah, a lot of those small parts, for example, for direction controller or some other controllers, they were created via node editor, and then in the Python scripts here in the rig generation code, we load them and connect them with each other, etc.
Oh, okay, let's move to the next question. Are you planning to make official shotgun plugin so it will be easier on developers to include Cascadeur into pipeline?
Well, not right now, to be honest. Not in the nearest future. We're concentrating a lot on our auto physics and auto posing tools, but maybe at some part of the time, I don't know. But we don't have any concrete plans for that right now.
The question is show how constrained weapon to hands. As far as I remember, there was several videos from Andre on if it.
Yeah, and actually, these constraints that we have here, they are basically there are some objects that were created in the node editor, and there's also some Python script that actually loads these objects and connects them with the objects in the scene.
Next question: can you show us how you made the mirror mesh animation of sword character you had in the demo? I think that it's question not for such kind of stream. I suppose that we will show this a bit later in stream with animators.
Yeah, we planned some streams with animators where they will actually animate in real time to show how you can use different tools.
How far away are we from the Windows management updates being able to tear off tabs like the graph editor?
We're pretty close to it. Actually, we plan that in the next version will be. I think the feature in the roadmap it's called layouts or something like that, but it actually includes the ability to tear off like different parts of the interface and put them in different windows and combine them. Combine this like parts of the interface. So I hope we will manage to do it in the next update. So far it's going pretty good.
Will you release a deep node editor manual?
Yeah, there's actually in the questions that were that in the list of questions I had beforehand before the stream for this topic. There's a question like that. What do we plan to expand the docs? Yes, of course we plan to expand the docs. Actually, we're already developing some additional documentation pages for the node editor, for the structure of the program, for Python scripts. So we do plan it, but that's actually a lot of information. So I think it will be hard to fit them only in the manual, and that's why we're trying out right now if it might be better to pass on this information via streams, or maybe we'll create some videos if streams don't work that good. But of course we plan to expand the documentation about all these topics. Maybe actually create some tutorials on our website tutorial page. So we're searching for ways to share this.
Good. So that is the last question from chat. I suppose that we can move to questions from Discord, from our friends from Discord.
Okay, let's see. It will be good to use not a for me, I thought it would be good to use node editor on mechanical rigs, but no, if that's the intention of the node editor. Well, node editor is very broad, so you can do basically anything with node editor, like create any data dependencies between the objects. Can they be used for mechanical? Yes, I think they can be used for mechanical rigs. We don't have some specialized nodes or presets for that, but there are all the basic operations, so you can probably achieve a rig like that. A way, so also questions for the stream. A way to implement squash and stretch scale in joints. Yeah, that can be done via node editor and I could say Python script, but it's a pretty tricky task to do. It's actually not done in a lot of software. I think because of the reasons it's pretty tricky. We plan to actually implement it ourselves. Have a task for it, and we already did some research. It shouldn't be that hard. So maybe if and I think this will be true for a lot of features of this kind, that if we do this feature inside, then maybe we'll make a stream about how we did it, what we had to change, how it works, what was done via node editor, what was done via Python scripts. So it's a good topic for such streams. Okay, changing color for rig controllers. Some people wanted. Yeah, you can actually change colors. Let's look at this example. We have a point here, and well, you can change color if in the behavior you actually have an option of changing the color. So you can see here in the point behavior that there is an attribute color, so you can actually create a new node, and the color in Cascadeur is set via the vector3 node, and I think color won't change based on time, so I created a static node. So now it has color. Let's make it a red color. Oh no, this is pretty sad. Not everything is going according to plan. The program crashed. Okay, let's see. I don't think it's a reproducible crash, but actually I think that I have not the latest version. Maybe it's a bit better in the latest version that is on the website. Okay, so now I can see color here. Let me change it. You can actually change the color of the controller. It's yellow now, so it's, but the color when it's selected I think is defined by the settings, and you can't change right now what color it has if it is selected. Don't know if that's a customization people really need. We can actually add that as well. Okay, a wheel rotating along its route when the route moves, kind of like a car, could be attached to a stick like a robot. So it's basically a dependency that says that if an object moves, for example, from some fixed position, then suppose this that's like a robot character that is standing on a wheel, and the wheel actually rotates whenever it moves. Sorry, probably a lot of you are animators, so you will be. So I'm really ashamed of my drawing. I know almost like animators usually draw really nice, so I suppose it's a robot. And when the character moves forward, the wheel rotates. So is that achievable? Yes, it's achievable. Maybe we can in one of the streams actually make a setup like this. Okay, let's move to the next questions. What other inference sources besides the official documentation will help in understanding the node editor better? So of course, knowing about node editors from other programs, the graphical programming things like, I know, blueprints in Unreal Engine would help, but it is very specialized, so I don't think it's like if you're only doing this for Cascadeur, I don't think it's worth like studying too much something else. Of course, if you do, it can help, but on the other hand, Cascadeur's node editor is of course it's much more raw and much less polished than in a lot of software, and it has a lot of small little features and things that are different. So I don't know, I hope that we will cover documentation in more detail. I hope that we will make streams like this one, and that we will be able to provide like enough sources of information to actually for our users to actually be able to use node editor. For now, of course, the documentation is very scarce. Are there any plans to expand the documentation? Yes, there are. Do you plan on adding hotkey customization to the node editor? I'd like to bind delete selected to the delete key. Yeah, sure. We do plan to do it. In fact, right now the task is in progress stage, and I think and yeah, and definitely in the next version it will be already you will be already able to customize and actually use the hotkeys in the node editor. Do you plan adding other types of constraints like orient, scale, aim, etc.? Yeah, we plan to add different types of constraints. Some of them are partially already added, but I think that's also as with the wheel rotating, it's also a great example of what we could potentially do on a stream to kind of show how all this infrastructure can be actually used in real life. Okay. If there are some additional questions, we can answer them.
Yes, so we have a couple of questions more. One question, just a second. Can the nodes be imported and exported like prefabs, so that the community could share the node setups with each other?
Well, basically you can save the node as a scene, and then you can load from Python scripts this load you can import from the scene the object that you want to import, and that's actually how, for example, that's actually how the root generation works. That's actually how the constraints work. For example, in this comments, let me show it because I think it can potentially be interesting. Okay. 1 second. I'll just get a bit ready. Not sure what. Okay. For example, these constraints, how they were made. Basically, it's I've created a scene like this, which contains an object, the constraint object, that is relatively simple, actually. Me show all the inactive nodes. That's all there is in this object, and you can see a lot of the setting nodes which actually customize when it's active, when it's not active. And then there's a Python script that loads this object. Like a Python script that actually loads this object and connects like this object to the points to the transform object, and then the points get constrained to the transform object. So scenes like this that are basically used as prefabs, and scripts that load them and connect them and attach them to the objects in the scene can without any problems be shared within the community, and we'll also I think create some of them, some of those scripts, and share them before releasing the next version if there are like some custom scripts that are really needed and can be interchanged. Okay. Maybe some other questions?
Sorry, microphone was muted. Yeah, we have for this moment last question. Do you plan to add recoil and deadweight ragdoll effects and or nodes?
Can you read it again, please?
Do you plan to add recoil and deadweight ragdoll effects and or nodes?
Recoil and
Deadweight.
deadweight. Okay.
Recoil is gun recoil.
Okay. Maybe I'm not familiar with this concrete types of nodes, but like if they're needed by the community and if it's like not extremely hard to implement them, then yes, we can add them.
Some clarification. Deadweight is someone going limp, like I had a character choked out, choke out another character. So I suppose that it's like the ragdoll effect of dead body on your hands. Some assumption like this.
Okay, it looks like it's something for now. Inside the node editor, you can only use something that works like in this frame. There's no there's no input like a frame number inside the node editor. So right now you can only control the update system, and it has to be indifferent to the frame number. So that sounds more like an effect. Like in Cascadeur's case, it sounds more like it will be like some kind of effect or interpolation type or something else, which can potentially be added if it's really needed. But I think I'll kind of investigate further and then maybe answer in the comments.
So just more a bit clarification. The Hi-Fi is asking for procedural generation of gun recoil and ragdoll, like you did with compensation and secondary motions.
Oh, I see. Yeah. Well, ragdoll. Okay, I finally understood. It's about the ragdoll. Yeah, we do plan to add ragdoll at some point of time. To do that, we have to include some collision library and like set it up, and that actually requires colliders to be set up inside the rig, which also will take some time. So we do plan it, but maybe not in the next release for sure. But I'd say it's rather midterm to long term plan, but we do plan to add it. Yeah. Okay. Are there any other questions?
No, I think that it was the last question, and well, we can say that if there any other mock will be questions about this stream or about next topics, you can always ask them in the comments, or you can ask us in Discord. And Alexander will prepare some interesting information for the next part of this series of stream.
Yeah, definitely. And if you have any ideas, also if you have any feedback, like, don't be scared to hurt my feelings. I think that I'll be able to send it. So, like, I don't know if the English is not good enough, if it will be better, like if doing it, like, I didn't prepare a video in advance, so I'm doing it live. But if that doesn't work out, maybe it's better to prepare some videos in advance and like just post videos on YouTube. Of course, the more polished it is, the harder to do like long videos that contain a lot of information. And I think that unlike the animation side, that is actually like that brings down the complexity of how you do animation. So it's easier to do animation in Cascadeur than in other software. We try to really lower this lower this boundaries. We try to really make it easy to get into animation via Cascadeur, and we will do it even more. So unlike in rigging and Python scripting, on the other hand, it's kind of the opposite for Cascadeur. Our rigging and Python scripting are created really low level, so you can change a lot of different stuff, but it is not like that much user friendly, because we're concentrated on making the animation process user friendly, and these are mainly tools that we use ourselves. Node editor, Python scripting, to create part of the infrastructure of Cascadeur, but we would really like to kind of move in the direction of making these tools also accessible, so that you can customize Cascadeur for yourself. You can create something and like share it with the community, and but we're really in the start of this path. So yeah, we'll be happy if you have any feedback or ideas how to do it better. We're always open. We read all the messages in Discord. So
And
I think
we are checking comments on YouTube. So I suppose that we can end the stream.
Yeah. Thank you everybody for watching.
And thanks for all, guys. See you next time.